Number 14 says, analyze the graph and answer the questions. So let's analyze our graph. First, it says where the holes are at, right? So here's a hole in the graph right here. And that hole looks like it appears at 1, 2, 3, 4, 5, 6, 7. This is the point of 7, 1. So the holes in this case is at x equals 7 at point 7, 1. Now, the zeros is once again the x-intercepts. So we want to look at where the function crosses the x-axis. And if you zoom in, the function crosses the x-axis at -2. Well, x equals -2 and x equals +2. So the zeros in this case occurs at x equals -2 and x equals +2. Now for the vertical asymptote, that is a vertical line that the function approaches on both ends, but does not touch nor cross that vertical line. So it's not visible in this graph, but we can, if you look at x equals, I want to say -4. I'm going to put that in red actually. I'm going to draw a dashed line. Don't mind the arrow. The arrow just indicates it's continuous. If you notice, if I draw a vertical line at x equals -4, the function approaches that line x equals -4 from both directions, but it doesn't cross nor touch. So my vertical asymptote is at x equals -4. And just for reference, I want to write the limit as well. The limit of the function when x approaches -4. Well, if you notice, on the left side, the function goes up. So on the right side, the function goes up. On the left side, the function goes down. It will never reach any defined value at -4. So that limit does not exist. Does not exist. D&E. And just going back to the holes for a second, the function is approaching, well, look here, right? The function approaches from the left side and from the right side. That approaches the hole at 7, 1. So we can say the limit of the function as x approaches 7, that's going to equal to 1. But we know that f of 7 does not exist. And it does not exist because there's a hole at the coordinate. The hole is not there. The limit approaches the value of 1 as x is closer to 7, but it doesn't exist at that point. Now, the horizontal asymptote is similar to the vertical asymptote, and that is a horizontal line that the function is approaching from both ends. But if you notice, there is no horizontal line the function is approaching, because as you look over here on the left side of the function, the end behavior, this is going further down, but on the right side, it's going further up. So there is maybe a slanted line that is approaching, but there is no horizontal line that the function is approaching in this case. Hence, there is no horizontal asymptote. No horizontal asymptote. You want to try to find somewhere where you can draw a vertical line, so a horizontal line, at a certain value of y, like I was able to do at the certain value of x, to find your asymptote. And then it says find the y-intercept, and you want to estimate that. Well, the y-intercept is where the graph crosses the y-axis, and it looks maybe about here. Let's put that in blue, actually. We know it's negative, and it's smaller than -1. So let's say approximately negative 0.25. This is not a definite answer. We're just estimating, right? So if you put like negative 0.3, negative 0.5, it's the same thing. So we can say y, which is also f of 0, is approximately negative 0.25. And last but not least, we want to write our domain. The domain is a set of all possible x values for the function. If you notice, we have two values that bring us restrictions. We have a hole at x equals 7, and we have a vertical asymptote at x equals -4. So when you write your domain of your function, D for domain, the domain is all x values except for -4 and +7. So it can be any x value that is smaller than -4, or it can be any x value between -4 and +7, or it can be any x value that is greater than +7. It could be any value of x except for -4 and +7. And that is how we analyze the graph and answer all the questions for question number 14. So hopefully this was helpful, and I'll catch you in the next one. Peace.